if x comma y is a solution to the system of equations shown below, what is the product of the x coordinates of the solutions? And this is a nonlinear system. This first equation is nonlinear. The second one is linear. But we want to find the solution, the x comma y pair that satisfies both of these equations. Well, lucky for us, both of these have been solved explicitly for y. So this thing is equal to y, and this thing is equal to y. So for the x and y where we get the solution, this thing must be equal to this thing right over here, because they're going to be equal to the same y. So let's do that. So we could view this as a substitution, that this is equal to y. So where we see y here, we can substitute it with 2x plus 7. So if we do that, on the left-hand side, you get x squared plus x plus 5 is equal to, instead of y, since y is equal to 2x plus 7, we could write is equal to 2x plus 7. And now let's see if we can solve for x. So we could subtract 2x from both sides. I'm doing that to clear out the right-hand side. And we could subtract 7 from both sides. And we are going to be left with, on the left-hand side, we're going to be left with x squared. X minus 2x is negative x. Negative x. Positive 5 minus 7 is negative 2 is equal to, well, 2x minus 2x is 0. 7 minus 7 is 0. That was by design. It's going to be equal to 0. And let's see, can I factor this quadratic expression? And if what I'm about to do looks like voodoo, I encourage you to watch the videos on Khan Academy on factoring quadratic expressions. But to factor, or at least attempt to factor, I have to think, well, are there two numbers whose product is negative 2, but if I were to add them, they add to negative 1. This negative x, the coefficient here, you could think of it as a negative 1. So let's see, well, negative 2 and 1, negative 2 and 1, their sum is negative 1. Their product is negative 2. So I can factor this as x minus 2 times x plus 1 is equal to 0. And you can verify that if you take the product here, you're going to get that over there. And so what are the x's that would make this, that would be solutions to this equation? Well, it could be the x that makes this expression equal to 0, which would be x is equal to 2. Or it could be the x that makes this expression equal to 0, because if either of these are equal to 0, the product is going to be equal to 0. So x is equal to negative 1. So these are the x coordinates of the two solutions. So one solution is going to be 2 comma something, and then the other solution is going to be, negative 1 and then something else. Now, if they wanted the solutions to the systems, you could take these x values and then substitute them back and figure out the corresponding y values. But for this problem, they don't even have to do that. They just say, what is the product of the x coordinates of the solution? So it's just going to be 2 times negative 1. So 2 times negative 1 is just negative 2. That's our answer.